Hey everyone, and welcome back for another deep dive. Today, we're going to be looking at the bridge design pattern in software development.
That's good.
And helping us out today, we've got a couple of sources. We've got excerpts from the Bridge article over at refactoring.guru and a transcript from Derek Banis's YouTube video, which is also about the bridge design pattern.
Yeah, should be interesting.
Yeah.
Yeah.
So let's unpack this pattern and see what it's all about. See how we can, maybe apply it in our work to write cleaner, more flexible code, all that good stuff.
Right. Well, it's really interesting. The bridge pattern tackles a problem that emerges as software grows, the complexity,
Yeah.
especially when you need to extend a class in multiple directions, like independent directions.
Right.
And that becomes pretty tricky.
Yeah, I remember when I first read about this, like the example from the refactoring.guru article really clicked for me. The geometric shapes example.
Oh, yeah, that's a good one.
Where they talk about having a shape class and then of course you have subclasses like circle and square.
Yeah.
And then you want to add colors. You want to have red and blue. And all of a sudden, you're potentially looking at this explosion of subclasses. Blue circle, blue square, red square.
Yeah, it gets out of hand really quickly.
Yeah. And that's only with 2 shapes and 2 colors.
Exactly. Imagine if you had, I don't know, like 10 shapes, 10 colors.
Right.
The problem just gets exponentially worse, right?
Yeah. Yeah, you end up with like 100 subclasses or something.
Yeah. And the core of the problem really is that we're trying to extend a class using inheritance, but in 2 independent dimensions,
Right.
which is shape and color. And inheritance, while powerful, can lead to this combinatorial explosion of subclasses, as you mentioned. And that just makes the code harder to maintain and understand.
Yeah. Makes it really messy.
Yeah, for sure.
So we have this problem, the potential for this subclass explosion. How does the bridge pattern help us avoid that?
Well, the way it works is it shifts the thinking from inheritance to object composition.
Okay.
So instead of cramming everything into one big class hierarchy, we extract one dimension into a separate class hierarchy.
Okay. So in our shape and color example, like we would pull the color out into its own hierarchy.
Exactly.
So we'd have like a color class with subclasses for red and blue.
Exactly. And then the shape class would just hold a reference to a color object.
Okay.
And it would delegate all the color-related stuff to that object. So it's like a bridge, right?
Right.
Between these 2 hierarchies. And this is really key because it allows them to evolve independently.
Yeah, that makes sense.
You can change or extend one hierarchy without affecting the other. That's one of the huge benefits of the bridge pattern.
Right. So like if we added new colors, it wouldn't impact our shapes at all.
Exactly.
And if we added new shapes, it wouldn't impact our colors.
Exactly. They're completely decoupled.
Yeah. Cool. Now, the refactoring.guru article also talks about abstraction and implementation.
Yes.
Which honestly sounded a little intimidating to me at first.
Yeah, those terms can sound very abstract, no pun intended.
Right.
But they really are the heart of this pattern.
Okay.
And the easiest way to think about it is abstraction is the what needs to be done, and implementation is the how it's actually done on a particular platform.
Okay.
That separation is crucial for flexibility.
So like in that GUI analogy from the article,
Yes.
the abstraction would be like the user interface itself, right?
Yeah.
Defining what the user can do, and the implementation would be like the operating system API.
Yes.
The actual code that's like carrying out those actions.
Right. And because you have that separation, the UI and the underlying system can evolve independently.
Right.
You could have multiple UIs,
Right.
each with its own unique look and feel, but they all work with the same underlying system. Or you could have one UI that works with multiple operating systems.
So they can both change without breaking each other, essentially.
Exactly. They can change without affecting each other.
Yeah, that's pretty cool.
Yeah.
Okay, I think I'm starting to get how these concepts, fit together.
With it.
But what about the actual structure of this bridge pattern? The article mentions all these different components.
Yes.
Abstraction, refined abstraction, implementation, concrete implementation, and client.
Right.
Can you break those down for us a little bit?
Sure. So abstraction is basically the interface for the control part of the pattern.
Okay.
It holds a reference to an implementation object, and it delegates all the actual work to that object.
Okay.
And then you have refined abstractions, which are basically variations of the control logic,
Okay.
but they still work with the same implementation interface.
So in our UI analogy, would that be like the abstraction would be like the basic UI functionality.
Yes.
And then the refined abstractions would be like different versions of the UI, like
Mm.
one for regular users and one for admins or something.
Exactly. So now on the other side, you have the implementation component,
Okay.
which declares an interface that is common to all concrete implementations.
Okay.
And the concrete implementations, those are the ones that have the actual platform-specific code.
So the implementation interface would like define the methods that the UI could call,
Yes,
and then the concrete implementations would implement those methods for different operating systems.
precisely.
Okay.
And then lastly, you have the client.
Okay.
The client is the one that interacts with the abstraction.
Right.
It's also responsible for linking the abstraction to a specific implementation.
Okay.
It kind of creates the bridge between the two.
But wouldn't this decoupling, I mean, wouldn't that add complexity?
That's a good point.
How do we make sure that both sides stay in sync?
Well, I mean, yeah, you do introduce a level of indirection, but
Yeah.
well, I mean, yeah, you do introduce a level of indirection, but it also makes it easier to manage changes in the long run.
Okay.
Think of it this way. By separating those concerns, you isolate the potential changes.
Okay.
So, like, if you need to modify the abstraction, you don't have to worry about breaking the implementation and vice versa.
Right.
So that modularity actually reduces complexity over time.
Yeah, that's a helpful way to look at it. So it's not just about, avoiding these subclass explosions. It's about creating a more modular and maintainable system overall.
Exactly. And that brings us to Derek Banis's perspective.
Yeah.
He offers a slightly different, simplified way of looking at the bridge pattern, which I thought was really helpful.
Yeah.
He focuses more on progressively adding functionality while separating out major differences,
Right.
using abstract classes.
Yeah, I really liked his remote control example.
Yeah, that's a good one.
Where he starts with this abstract entertainment device
Yeah.
class that defines the common functionality.
Yeah.
Like volume control and stuff.
Right.
And then he's got concrete classes like TV device and DVD device
Yeah.
that, add their specific features.
Exactly.
And on the remote control side, he's got like an abstract remote button class
Right.
that defines common actions, and then concrete remote classes, like TV remote mute, TV remote pause,
Exactly.
that add those specific functionalities.
Right. It's like building these layers of abstraction
Yeah.
where each layer adds more specific functionality,
Right.
but it still relies on the common interface defined by the abstract class.
Yeah, so it's like each layer kind of builds on the previous one.
Right.
It's providing more specialized behavior,
Right.
but it's still like adhering to that common interface.
Exactly. And that keeps the code very clean,
Right.
organized, and maintainable.
Okay, so we've seen some cool examples.
Yes.
Let's zoom out a little bit.
Sure.
What are the broader advantages of using this pattern? Both of our sources mentioned some key benefits.
Yeah. Well, one of the biggest advantages is platform independent development.
Oh.
By separating the abstraction from the implementation,
Right.
you can write code that works across different platforms without having to modify it.
Yeah, that's a big deal, especially nowadays, right?
Yeah, huge.
Like everybody's got different devices, operating systems, and
Exactly.
it would mean a lot less code duplication,
For sure.
easier to maintain. I could see how that would be really valuable for like developers working on cross-platform applications.
Absolutely. And it also hides platform details from the client.
Okay,
So the code is cleaner,
right.
easier to understand.
Okay.
The client only has to interact with the abstraction. It doesn't need to know about all those concrete implementations.
That actually reminds me of something I've been wrestling with in my project.
Oh, yeah.
Yeah, I've got like this logging system, right?
Okay.
And it can write to like a file or a database
Yeah.
or, just the console. And right now it's kind of all mixed together.
Okay.
It's getting pretty hard to manage.
Yeah.
Could I use the bridge pattern to like separate out that logging logic?
Absolutely. That's a perfect example.
Right.
You could have an abstraction for the logging functionality
Right.
and then implementations for each output destination.
Oh,
It's
okay.
like one for file, one for database, one for console.
Okay.
And then that way it would be very easy to add new destinations in the future
Right.
without having to modify the core logging logic.
That's a really cool idea. I'm gonna look into that. So, okay, to summarize, we've seen that the bridge pattern is a powerful tool for managing complexity, creating flexible and maintainable software. It lets us decouple abstraction from implementation, which enables platform-independent development. It lets us divide monolithic classes into more manageable hierarchies, so it improves our code organization and maintainability. We can extend classes in multiple independent dimensions, avoiding that combinatorial explosion of subclasses that we talked about. And we can even switch implementations at runtime. That gives us flexibility and adaptability. Wow, that's quite a list.
Yeah, it's pretty powerful.
Yeah. And before we wrap up, I just want to highlight something that both sources mention.
Hmm.
The difference between the bridge pattern and the strategy pattern.
Right. Good point.
Because at first glance, they seem kind of similar.
Yeah, they do. They both involve delegation and composition,
Right, yeah.
but the intent is quite different.
Okay.
With the strategy pattern, the focus is on encapsulating algorithms
Okay.
and making them interchangeable. Right. Whereas with bridge, the goal is to separate the abstraction from the implementation so that they can vary independently.
Okay, so with strategy, you're choosing different ways to do something.
Exactly.
And with bridge, you're separating concerns and enabling, like, independent development of those concerns.
Precisely. Yeah. So like with the strategy pattern, you might have, different sorting algorithms that you could swap out depending on the situation.
Right.
But with the bridge pattern, you're separating the core functionality from like the platform specific details.
Okay, yeah, now I see the distinction.
Yeah.
It's subtle, but it's important.
It is.
So to our listener, I want to leave you with a final thought. Think about your own projects.
Yes.
Are there any areas where you could benefit from the bridge pattern? Could you use it to decouple components, improve flexibility, or just simplify maintenance? What do you think?
Well, when I first encountered the bridge pattern, it felt kind of abstract and theoretical, to be honest.
Yeah.
But once I started seeing it in action and using it in real projects, I realized how powerful it could be. It really can elevate your software design.
Yeah, it's definitely one of those patterns that, takes a little effort to wrap your head around.
Sure.
Yeah, it's definitely one of those patterns that you kind of have to, you got to see it, you got to use it, and then it kind of clicks.
Yeah, for sure.
And then you start seeing it everywhere.
Exactly. It's like, oh, I can use that here. I can use that there.
Exactly, yeah.
Yeah.
So to our listener, think about your own projects,
Yeah. Yeah.
Are there areas where, maybe this bridge pattern could be a good fit?
Yeah.
Could you use it to decouple some components or improve flexibility or simplify maintenance? Just, think about those things.
Yeah. I mean, there are so many possibilities, right?
Yeah, absolutely. And, we've just scratched the surface here today.
Yeah.
But hopefully, this has given you a good starting point, to explore this pattern further, see how it might fit into your work, and, maybe even start using it to write better code.
Right.
So keep those coding brains engaged. Stay curious. And, thanks for joining us on this deep dive.
Yeah. Thanks for having me. It was fun.
I will catch you next time.